Alright everyone, this is 2.4 part 2, all examples, all the time. So we're going to start with this example. We did example 1 with the gears, now we're doing example 2, decomposition of a function. We're not even going to worry about doing anything with derivatives or differentiation. We just want to be able to rewrite these functions that we have right here in the two parts that we need, because we have a composition, right? We've got a fraction and we have x plus 1. So we want to be able to go through this and just write it out as what is g of x, what is f of u. Okay, so u in this case is going to be the stuff that's in the bottom. It's like the stuff that's inside, all right? So u is going to be x plus 1. All right, so that is our u, and our y equals f of u is the bigger function. It's going to be like the 1 over x function, or 1 over u is probably a better way of writing it. So we're not going to do that. I'm going to say 1 over u. That way we don't get confused as to what we have and what we need to do. All right, so x plus 1 is our g of x function. Our u function is going to be the 1 over the x. All right, so now let's look at this next one. Remember, the u function, the g of x part, the one that you're going to be writing the x, is the smaller part. So what's the smaller part in here? Well, it's really this 2x, right? So we've got 2x is our g of x function, and the bigger thing, we're just going to replace that 2x with a u, is going to be the 2 sine u function. Okay, there you go. So what your assignment is going to be tonight is to do these two. Figure out what u is for both of them, and figure out what g of x is for both of them, and figure out what f of u is for both of them. Remember, it's the inside part that's the u, and the larger part is going to be the f of u. All right, so that is your assignment. We are going to go through some more examples just so that way you get the hang of it, though. All right, so here is example 3. Using the chain rule, find dy over dx for y equals x squared plus 1 cubed. So example 3 says this whole thing. So what we're going to do is first I want to find what is u, which is the g of x, and I also want to find out then what is the f of u, the bigger part. Okay, so the u part is going to be this thing that's under here, right? It's inside the parentheses, it's the smaller part, which is going to be x squared plus 1. And the f of u is just going to be this bigger thing, u cubed. All right, so we have those two. Okay, so now what we are going to do is let's figure out this whole thing using what we know from the general power rule, is that we can say this is going to be 3u squared. Okay, and then using what we know about this one, that is going to be f prime of u. So we can say f prime of u equals that. And we can say u prime is going to equal the 2x. Okay? So far, so good. Alright, so now what I have to do is we know what u is, right? This whole thing goes in for that u. And then we just have to remember the chain rule said multiply our two derivatives together, our two rates of change together. So I can say this is going to be 2x times, I've got 3, parentheses, x squared plus 1 squared, right? I did the 3, went here, the u I changed back to what u was, and the square was right there. Alright, so I've got 2x times 3 times x squared plus 1 squared. Now that's not a great way of writing it. We could say this would be 6x, parentheses, x squared plus 1 squared. And that would be our answer. Alright, looking at the power rule, if y equals u of x to the n, where u is a differentiable function of x and n is a rational number, then dy over dx equals n u of x n minus 1 times du dx. So basically the power rule is something you already know, and now what we're going to do is we're just going to use it again, except now we're going to say that if u is a function, we can use the chain rule as well. Okay, so we have different ways of writing it, and really all the other thing we can say is that y prime equals n u to the n minus 1 times u prime. Okay, so here's our example 4. Find the derivative of that whole thing. Okay, so what we're going to do first is I'm going to use that power rule to say f prime of x is going to equal, that 3 goes here, and it's going to be whatever I have left inside of u. So u is going to stay exactly the same. And my hand is somehow frozen. See? Okay, good. and I will put in the 3. I'm going to actually put this in a different color. The 3x minus 2x squared. And that's going to be to the n minus 1, since it was 3, now it's 2. And then I have to multiply that by the derivative of u. So what's the derivative of u? The derivative of u is the stuff inside, so I can say that's going to be 3 minus 2 times 2 is 4x to the first. I don't have to write it, and I can just put it right here like that. And there is our solution for f prime. And here is example 5. Find all points on the graph of f of x equals a cube root of x squared minus 1 for which f prime of x does not does equal 0, and for those for which f prime does not exist. So the first thing we are going to do is we're going to rewrite this. I don't like the radicals. You probably don't either. So we can rewrite this as x squared minus 1 to the 2/3 power. All right, and then we're going to be able to do our chain rule and stuff like that. Let's use a different color. That blue one's getting a little bit thick. So I'm going to say this would be, so we're going to say that is our function, f of x. And now we're going to say f prime of x equals, f prime of x is going to equal, I'm going to do the power rule first, the 2/3 x squared minus 1. And 2/3 minus 1 is going to be negative 1/3. All right. Whoa. This is really slow and you can't see it. That's not good. That's not good at all because I just wrote it in, but it's not there. Well, let's see what I can do about this. All right. Sorry, ladies and gentlemen, we had some technical difficulties, but we are back. So I think we left off f prime of x equals, I did the chain rule of the big function, and now what I have left to do is do the stuff with the x squared minus 1. So the x squared minus 1, that expression, and when I find the derivative of that, is just going to be 2x. Right? Minus 1 doesn't really do anything. So what we're left with is the 2x all over, and I'm just going to write the rest of it. Since it's a negative exponent right there, that means it's going to jump down to that denominator. So we're going to have 2/3. And then we're going to have the cube root of x squared minus 1. All right, so there we go. Excuse me. All right, so now instead of having the 2/3 in the denominator, multiply by the reciprocal, and the 2's will cancel out, and I'll be left with, and I think I can write it right here. I have just enough room. That is going to be the 3x over x squared minus 1 all under the cube root. So it's 3x over the cube root of x squared minus 1. And I can tell you that I just made a mistake. First one ever, you can mark it down. Because this 2/3 is actually not with that negative exponent, so I can't multiply by the reciprocal. So when I did this part right here, that was wrong. There we go. So what I'm going to do is I have just enough room over here. I know this is probably not what I should do, but I'm doing it anyway. F prime of x is going to equal that 2/3 times the 2x on the top over the cube root of x squared minus 1. So it's really going to be 4x, and I'll just write it down here. That way we have nice amounts of room. We can just say that f prime of x is going to equal 4x over 3 and the cube root of x minus 1. There is our answer. Now you can see it. Okay, so there is example number 5. Example number 6 says differentiate g of t equals -7 all over 2t to the 2t minus 3 squared. So what we're going to do here is I'm going to rewrite this as -7. So g of t equals -7 2t minus 3 to the -2nd. All right, so now from here what I can do is I can rewrite this as this -2 goes in the front, right, using the chain or the power rule. So -2 times -7 is going to be 14, 2t minus 3 to the -3rd. And then I also have to find the derivative of the stuff in the middle, which is just going to be 2. Okay, so now what we're going to do is we can do 2 times 14. We get, so we can say g prime of t equals, and 14 times 2, we get 28. And since this stuff is negative, notice how I didn't put the 14 in the denominator this time. This stuff is going to be the negative, so that means I can put that over 2t minus 3. I'm going to put it all in parentheses to the third power, and then we have it all complete. There you go. All right, next we're going to do example number 7. Simplify the derivative. F of x equals x squared times all of that stuff. Okay, this is going to be a little bit complicated, so I'm just going to rewrite this down here because I know I don't have enough room for it. So let's just roll this over and see if we can do this. All right, so the first thing I'm going to do is I have to do this one times this one. There's all sorts of multiple steps we're going to do, so let's take a look at how to do it. All right, first step we're going to do is f of x is going to equal x squared, and that's going to be times 1 minus x squared to the 1/2. All right, so now we've got two things, the product rule, I believe, so we're going to do f prime of x is going to equal the x squared times the derivative of this whole thing, which is going to be 1/2 times 1 minus x squared to the negative 1/2 times, we got to do the stuff on the inside, negative 2x, because it's a minus here, so we do the negative 2x. So I really did the chain rule for this one, and now we're doing also the product rule for that part. Okay, so we did that part, and then it's going to be that thing plus the original one here, and I know I'm not going to have enough room, so I'm just going to put this down here, 1 minus x squared to the 1/2 times the derivative of x squared, which is going to be times 2x. And now we just have to put them all together. Yuck. All right, so that is what this can look like for now. I'm going to go through and see if I can get this to look a little bit easier and nicer for you. All right, so we can say we got x squared times negative 2x times 1/2. So the 1/2 and the 2 cancel out. We end up with negative x cubed. And then we have 1 minus x squared to the 1/2 plus, and I'm just going to say 2x times 1 minus x squared to the 1/2. So we can rewrite this a little bit nicer, negative x cubed, and this should be a negative 1/2 over 1 minus x squared, take the square root, plus 2x times this, I'm just going to say the square root of 1 minus x squared. All right, and so that is our f prime of x. That really seems, oh, you can't see it. I'm really sorry about that. F prime of x is going to equal all that stuff. Can we go through and simplify this a little bit further? Sure, you could if you wanted to. We could take this, multiply by the square root of 1 minus x, and if I do that, the numerators will cancel out, so I'm left with negative x cubed plus 2x all over the square root of 1 minus x squared. And there is that example number 7. All right, so here's the last thing you're going to look at, and these are the trig functions. I'm not going to go through them all because you have the ability to pause. So go through, make sure you know what the trig functions are. It's the exact same as the other trig functions, but now we've just included the u prime. Okay, so there is your second example on the chain rule.